Okay, and we're going to answer some more information that we have answered before. So pay attention, because I may call on you to answer some questions here. Now, if you do not have a copy of the periodic table pulled up, go ahead and pull one up on your Chromebook. Just look up periodic table, okay, and pull it up. Peyton? What?
There's some in the packet.
Yeah, that's true. There are small copies of the periodic table. There's like 4 of them on 2 pages. Yeah. What page is that, Peyton? 14 and 15? 13. Sorry. They are really small, so if you can't see those in the dark, you can pull one up. But we're going to be working off of the information from the periodic table here. So, all right, carbon. Okay, what is the atomic number of carbon? Alex? Say 20? All right, look. Carbon is C right here. Yes, 6. Okay, 6. And then there is a difference between atomic mass and mass number. There are times where they're used interchangeably, but in general, atomic mass, when that is said, usually it refers to the average atomic mass, which is the mass that's going to be listed on the periodic table. So carbon's is 12.011, and the unit would be AMU. All right, how many protons does carbon have? Let's see. Kendall, what do you think? How many protons does carbon have? What's its atomic number? 6. So it should be the same as the atomic number. All right. Now, we're going to assume that the mass number here is 12. So the atomic mass would be 12.011. So if the mass number is 12, how many neutrons are there going to be, Marley? How many neutrons would you have if the atomic number is 12, number of protons is 6? How many neutrons would that make it have?
2, 9, even 6.
Yeah, that's right.
Oh, cool.
Okay? 12 minus 6. Mass number minus number of protons. All right. How many electrons would it have, Aiden?
6.
If it's neutral, it's going to have 6, which we're going to assume that these are neutral. All right. Now, this brings us to something new here called a Lewis dot structure. Okay? Now, a Lewis dot structure tells us how many electrons that an atom has in its outer energy level. Okay? All right. So look, I'm going to make this real easy for you. Depending on what column it's in, and we're only looking at the tall columns, but depending on what column it's in, that tells you how many electrons it has in its outer energy level. So this would be 1, 2, skip these short columns, and then 3, 4, 5, 6, 7, 8. Okay? So carbon is in column 4. So that means it's going to have 4 outer energy electrons. So what we would do, draw the symbol for carbon, which is C, and then we would put 4 dots. And that is the Lewis dot structure for carbon. Now, the key here is don't pair these up until you absolutely have to. So don't put like 2 dots here and 2 dots here. There's 4 sides to any symbol. So you should, like if you had 5 dots, then you would have to pair up 2 of them. But with 4, I can put 1 on each side. All right? Because electrons are negatively charged and they generally don't want to pair up until they absolutely have to. So spread them out. All right, now, these have a specific name. Okay, these are called valence electrons. Valence. All right? And these are electrons in the outer energy level. All right? So, whenever we draw a Lewis dot structure, that is all we are concerned with are the valence electrons, the electrons in the outer energy level. So carbon has 4. Now, total electrons, carbon has 6. But we're only concerned about the ones in the outer energy level. So that's why we have 4 here. Okay, for hydrogen. All right, what's the atomic number of hydrogen? Caleb. 1. It's the very first element on the periodic table. What is the atomic mass of hydrogen? Brian?
1.
Well, we're not going to round this one here. We're actually going to report what's on the periodic table. So 1.008 AMUs. But we would round that down to 1 for the mass number. All right, how many protons is hydrogen going to have? Peyton? Just 1. Okay, atomic number is 1, protons are going to be 1. All right, how many neutrons? Aiden? 0. Okay, there are 0. All right, how many electrons? If it's neutral. Emma? Just 1. Good. Okay? So for hydrogen, the dot structure, we would draw the symbol H. And then you would just put that dot right there. Just 1 electron. All right, now, looking at the periodic table, I want to tell you this. Okay? These elements right here in the 8th column, these are the noble gases. All right? The noble gases, they are the most stable elements on the periodic table. Most stable. All right? And the reason for that is because they are all the way at the end. They are completely filled up. Their outer energy level is completely filled. And it has 8. Okay? 8 valence electrons. All right? So there's a rule that applies here. It's called the octet rule. All right? And what it says is that elements want... Oops, fell into a hole there. Elements want 8 valence electrons. Okay? So that's the reason why elements will bond. Is because they want to try to either gain 8 electrons. Sometimes they'll lose electrons to be able to empty out their outer shell so that they will have a filled outer shell. And then sometimes they will share with other atoms to be able to get 8 valence electrons. But regardless, they're going to do what they can to be able to try to get 8 valence electrons. Now, there's only 2 elements on the periodic table that do not want 8 electrons. And those 2 are hydrogen and helium. Hydrogen and helium. Because they exist where their first energy level is the only energy level that they have. And the first energy level can only hold 2 valence electrons. So they only ever want 2 valence electrons. So that's called the duet rule. But that only applies to hydrogen and helium. All right, here's a fun English fact for you. Did you know that there's two ways to spell the word gases? So there's G-A-S-E-S and there's G-A-S-S-E-S. Does anybody know the difference? This is the plural form of gases. This is actually a verb. It's an action word, like Mr. Harrington gasses up his car.
Oh, we can't see it.
Whoops. So there you go. Now you know. That will not be on the test, just so you know.
You gassing up your car?
Yes. All right. Let's do a few more examples here. So, lithium, which is right here, what is its atomic number? Kyle. Didn't you have your hand up? It was up. You might not have meant to, but. All right, can you tell me? Of lithium. Li, right here. 3. There we go. And the atomic mass, 6.941 AMUs. All right, how many protons is that going to be? Melody, can you tell me? Yeah, that should also be 3. Very good. And let's assume that the mass number is 7. All right, so how many neutrons would that give us, Brian?
4.
That would give us 4. Okay? And if this is a neutral atom, how many electrons would we have? Maddie, can you tell me?
3.
That would also give me 3. Should be the same as the number of protons. And so for lithium, what column is it in? It's in column 1. So it's going to have 1 valence electron. So that's what it would look like. All right, let's see if we can find something a little bit more difficult here. Okay, let's look at oxygen. We'll do a couple more here. All right, with oxygen, what is the atomic number of oxygen? Oxygen's right here on the periodic table. What is it, Peyton? 8, okay? So go ahead and put 8 right there. And then the mass, 15.999 AMUs. And then what comes next? Number of neutrons? Yeah, number of neutrons. So let's assume that the mass number is 16. How many neutrons would that have? Brian, go ahead.
16, that'll have 8.
Yeah. It would have 8. So 16 minus 8. And then for the number of electrons, how many electrons is it going to have? Jeremiah, can you tell me? How many electrons? If it's got 8 protons?
8?
Yeah, should have 8. Okay. Wait, am I on the right column?
No.
Oh, I'm not. Well, good thing it's still 8 protons, 8 neutrons, and 8 electrons. So we didn't mess up, but I was on the wrong column. All right. Now, the Lewis dot structure for oxygen. Okay, look where oxygen's at. Count over the columns right here. So you got 1, 2, 3, 4, 5, 6. So oxygen is in column 6. So that means we got 6 dots. 1, 2, 3, 4, 5, 6. And that is the dot structure for oxygen. All right, is everybody with me? Anybody not with me? Okay, let's do one more. Let's do fluorine. All right, fluorine, right here. How many, what is the atomic number of fluorine? Zoe. It is 9. And the atomic mass, 18.998 AMU. And number of protons. How many protons does fluorine have? Brian?
10.
Say 9 or 10?
I'll see if you line it. It'll be 9.
Yeah, it would be 9. Should be the same as the atomic number. And then if we assume that the mass number is 19 by rounding it up, how many neutrons is it going to have? Say them?
10.
Yeah, should have 10. And how many electrons? Somebody who hadn't answered. Anybody? It's a neutral atom. It should be easy. All right, Brody. Yeah, should be 9. Okay? 9 electrons, 9 protons. And then if we look at the number of valence electrons, so fluorine's right here. This is column 7. So you get 1, 2, 3, 4, 5, 6, 7. And that is your dot structure for fluorine. Anybody have any questions?